All right, everybody. My name is Eric Hayden. I am a meteorologist with the Weather Service here in Newport, Morehead City. It's just about 7:30, so we'll get started. I heard from one gentleman already, so our audio should be good. If you see the screen that says Basic SKYWARN Online Training, you're all set with that. In case you have any internet difficulties, we sent you a copy of the PDF of tonight's presentation. So if you have any troubles with the internet speed or anything like that, you can just pull up the PDF file itself and follow along. I don't hear a lot of background noise now, so we'll keep the phone lines open. If we do get some background noise, if you don't know how to mute your phones, we can certainly mute everybody so we don't have to worry about that. So hopefully everybody's all set to get started. I appreciate everybody joining us. I know it's a pretty nice evening across our area, so really appreciate you taking the time to take this Basic SKYWARN class. And this is actually our second year of doing these classes. Our hope is that you learn a little bit more about who we are as the National Weather Service, a little bit more about severe weather, but the main focus is going to be emphasizing what to report to us in terms of severe weather. Later tonight, you'll get a certificate of completion sent to the email that you registered with. So just sit back and enjoy this class, about 50 minutes, and then we'll certainly hang on for any questions that you have at the end. This is our Basic SKYWARN class. The main crux of this class, once we get through who the Weather Service is and what SKYWARN is to talk about thunderstorms, spring and summer severe weather. So thunderstorms, tornadoes, we're going to go over what squall lines are, tornadoes, flash flooding, and again, we'll review the spotter procedures that we want you to report with. We're going to give you some science. We don't want you to focus on that too much. That's just more for your own knowledge. We're going to highlight in yellow what we want you to focus in on, and that will be things such as reporting to us when severe weather happens. Did we have any questions out there? Or so I'm going to go ahead and mute the lines just so we don't have to worry about any background noise. But again, if you can see me, see the presentation, and hear the audio over the phone line, you are good to go. And it looks like we have just about pretty much everybody that has signed up for the class. I don't see any questions out there either. So I'm going to mute the lines.
The conference is now in silent mode.
So now you don't have to worry about the background noise. If you do have a question, something's gone wrong, or you just have a question about the class itself, feel free to use the software. Really nice software, and I'll get to those questions as we get toward the end. So again, we're going to talk about science, but our main goal with this class is that you report to us when severe weather happens. Is it good to know how a thunderstorm forms? Sure. Is it good to know the different life cycles of a thunderstorm? Yes. But our emphasis will be when you get high winds, hail, or heavy rain, or even a tornado. Please let us know about that. So kind of sit back and relax. We'll go over the next couple slides. We'll focus on who the Weather Service is, and we'll talk a little bit more about the SKYWARN program itself. Why do we actually need spotters? This slide is emphasizing our main mission in the National Weather Service is to protect life and property. So while we do a 7-day forecast and we tell you what the weather is going to be, our main focus is the big weather, and that's what we issue watches, warnings, and advisories for. We're the only agency that does that. We fall under the Department of Commerce and NOAA, and we certainly rely on our TV partners in the broadcast sector, cell phone companies, so that you can actually get those alerts to relay the message, but we're the folks that are issuing those products to protect you, again, from bad storms, ranging from blizzards to hurricanes to flooding. How we do that is we have a bunch of localized offices across the country. On this map, you'll see we have over 100 offices. This kind of looks like a jigsaw puzzle. We'll talk about how this part of the class, or this class itself, focuses in on Eastern North Carolina. I know we have folks from Kentucky and Virginia on the class. At the end, we'll talk about how you can get associated with your local office for reporting. The reporting is the same whether you live in Kentucky or Eastern North Carolina. The main difference is you want to get hooked up with your local office because you folks will have a different email address, a different phone number that you'll call. So that's the thing we'll have to get you hooked up with here at the end of class. As far as our office is concerned, a lot of folks have joined us from the Outer Banks down through Morehead City and Jacksonville and Greenville. That yellow area is the part of North Carolina we cover. roughly the eastern or southeastern quarter of North Carolina. If you live across northeast North Carolina, you folks are covered by the Richmond or Wakefield office. The central part of the state is covered by the Raleigh office, and far southeastern North Carolina, right along the border with South Carolina, is covered by Wilmington. You'll notice that yellow area extends out into the ocean. We cover, in terms of forecast and warnings, out to 20 nautical miles. And then between 20 and 60 nautical miles, we do warnings for that blue shaded area. Those are some pictures of our office. You'll see a Doppler radar behind the office. And also that dome-shaped picture, the picture on the right, that's where we launch weather balloons. In fact, Bell, one of the people that I'm working with tonight, just did the weather balloon. We do that twice a day at 7 a.m. and 7 p.m. all over the world so we can measure what is happening above us. One important thing to mention is we are open 24/7. So like a lot of police and fire and first responders, we are here and staff for emergencies. Weather doesn't happen 9 to 5, off on Thanksgiving and holidays. It happens when it's going to happen. And that's why we have a staff of between about 20 and 25 of us that are here to support you. And this includes during bad weather. So Hurricane Florence, our entire staff was here spending the night through the storm to serve you. Again, that main mission of protection of life and property. So that's a little bit about the Weather Service. Again, a lot of offices across the country. One main reason for that is we can give you a nice localized forecast if we're living in the community that we serve. Now, where SKYWARN comes in, it's a volunteer program run by the Weather Service to provide us with ground truth reports of what's happening. What we mean by that, it sounds fancy, but what is or is not happening on the ground at your location? We've got Doppler radar that's looking up in the sky, and we can surmise that heavy wind or rain or hail is making it to the ground, but spotters actually can confirm whether that's happening or not. So they're certainly important for our warning decision process. A couple different ways that spotters can help us. Really gauging the storm itself. One example would be, let's say there's a big storm that has gone over the Greenville, North Carolina area. I'm getting ready to issue a warning, but before I do, I get multiple reports of very small hail. Winds are not as bad as I think it is. And because of that, I withhold issuing a warning. So I'm not crying wolf. I'm not issuing a warning when it's not needed. That's life-saving information because I'm not warning when I don't need that warning to be issued. Now, another scenario, let's say there's a storm west of Greenville, Snow Hill, or maybe south and east over toward Kinston, and a spotter confirms that we have baseball-sized hail or a large tornado or very, very strong winds. I can still have that warning issued, but I can put that information into the warning so people downstream take it serious. We get warnings all the time on our phone. Folks all the time say, oh, it's not going to happen to me. I've seen this before and I've been just fine. But imagine if those people see a town that's the next one over. Imagine if they see a city in there they recognize and the warning says that, hey, this is actually happening. A train spotter has confirmed it. It really adds more validity to the warning itself. And that's why we try to stress that the train spotter is still one of our greatest assets, despite the technology we have in terms of reporting severe weather to us. A couple definitions I want to go over. Watch, warning, and severe thunderstorm. A watch for any type of weather just means conditions are favorable for it to happen. Doesn't mean to cancel your plans. Just means to keep in the back of your head that, hey, all the ingredients are there for this type of weather to happen. I love eating. I love cooking and baking. So an example of that would be you're making brownies. You've got the oil, the water, the flour, the brownie mix all out on the counter, and your oven is preheating. Hasn't happened yet. You're not eating the brownies. They're not cooked, but all the ingredients are there for it to happen. Now, a warning means it's imminent or occurring. In this case, the brownies are in the oven and they're baking. So all our ingredients have come together and it is actually happening. So tornado watch means, hey, pay attention to the forecast, be ready to receive warnings, have a plan of where to go if one is issued. Then when a warning is issued, that's when you need to take your action, your plan, and make it an actionable item. As far as severe thunderstorms go, you'll notice that lightning is not on there. Lightning is certainly deadly, But if we issued a warning for every thunderstorm here in eastern North Carolina, we may be doing it 4, 5, 6 days of the week once we get into the heart of the summer. So the Weather Service, we focus on things that would cause damage, something measurable. So we're talking inch diameter hail or larger, or wind gusts 58 miles per hour or stronger. And that's the rough threshold when we start to see some larger branches down, maybe some damage to your car, your house, or for farmers, their crops. So those numbers aren't just made up. That's roughly the area we start to see damage in terms of wind speed or large hail. A couple other definitions I want to go over, tornadoes and funnel clouds. You might say, Eric, I know this is a basic class, but doesn't this really seems really basic? I want to focus in on this, and what this is we're talking about something rotating. We are talking about something that is either in contact with the ground or not in contact with the ground. So with a tornado, it's got to be a violently rotating column of air in contact with the ground. The key words are in yellow. Has got to be rotating, and it has got to be in contact with the ground. With the funnel cloud, it is also rotating. So that's a key there, but it is not in contact with the ground itself. And because of that, it is just considered a funnel cloud. But again, the key out of all this, it has got to be rotating. I see we do have one question already from Lisa. When a funnel cloud or tornado has been spotted, do we call the emergency contact information for the National Weather Service first or 911? We would like you to call us. The 911 center can relay that information to us. But if we don't have a warning out, or maybe we need to do an update or add some information, we can certainly do that the fastest. So what I would recommend, again, is for you to call us. And we're going to go over that, Lisa, and others as we head toward the end of class itself. So we'll kind of cover that in terms of the reporting section on what to do in terms of the different types of weather. As far as the Weather Service goes, we do a lot of information on our website. It's weather.gov. If you put the /MHX, you'll get the Eastern North Carolina page, which is our local office. You don't need the HTTP. You don't need the www. So if you just do weather.gov, anywhere in the country, you can click on your region of interest and you can get a local forecast. A lot of good information on here. The page itself will light up with different colors based on what's happening. So if it's a completely blank map, that's good news. That means the weather's quiet. If you have various colors, that means things are happening. You can get your forecast itself many different ways. You can click on the map, zoom in on the Google map that pops up, or you enter your city or zip code. So a lot of good information that's free and at your fingertips. And again, no matter where you go in the country, if you just go to weather.gov, you can get that information. One site I'll go through just a little quicker, but it's really for the weather enthusiast, or if you're really into severe weather and you want to know more. The Storm Prediction Center is located in Norman, Oklahoma. This is really the sister office to the National Hurricane Center. So those folks down in Miami are experts on the tropics. The folks in Norman, Oklahoma, they are experts on severe weather, tornadoes, severe thunderstorms, large hail, damaging winds, that type of thing. They do a forecast out to day 8 to highlight the potential for severe weather in different risk categories. So it's a good first source for knowing what's happening down the road. Then as we get a little bit closer, they'll work with us on issuing tornado watches and thunderstorm watches. They'll kind of come up with an outline. We may massage it a little bit and go back and forth, and then they'll issue the watch itself, and then we'll take over with the warnings on a local level. So spc.noaa.gov, very, very good site. We had a bad outbreak a couple days ago. They did an excellent job highlighting that threat many, many days out. And speaking of that, they're focusing on a potential for some severe weather around our neck of the woods sometime later Friday and Friday night. They have us in a higher risk for the potential for severe weather during that time. So again, really good folks, knowledgeable, again, with regards to severe weather. So talked about who the Weather Service is, fall under the Department of Commerce and NOAA. Main mission is to protect life and property. Only about $7 a year to fund us. And again, that includes not only us making the forecast, but all the radar and satellite data that you have direct access to, or maybe you see on television. The next couple slides, since this is a basic class on severe weather, we want to touch a little bit on thunderstorms. You need the ingredients to be together for them to form. And those three ingredients are moisture, instability, and lift. Instability, anytime you think of that, just think of fuel for the thunderstorms. Higher instability, more fuel, more potential for those storms to be bad. The first ingredient, moisture, we usually don't have to worry about. Can we have a drought in eastern North Carolina? Certainly. Can we be too dry to have thunderstorms or rain? And we have something called virga, where the precip evaporates before it hits the ground. Yes. But by and large, because we're surrounded by so much water and our prevailing flow is from the south, so it's either coming from the Gulf of Mexico or the Atlantic Ocean, we have plenty of moisture. Don't really have to worry about that. The next ingredient that we can lack sometimes, especially the first part of the season, maybe in the wintertime as well, is instability, and that's fuel for those thunderstorms. It's really cold versus warm air. A couple ways to think about it. Think about a hazy, hot, and humid day. It's 90 degrees here at the surface, and if you were to take a plane or just go up in the atmosphere, as you get higher into the sky, it naturally gets cooler. That's normal, and that's normally what happens. Well, if you get up in the atmosphere and you get cold very quickly, that's a very unstable atmosphere because that warm air at the ground, it naturally wants to rise very fast and quickly because it's very buoyant, very light compared to that surrounding cold air above. So that's an unstable atmosphere, really cold at the surface, really cold aloft. Another way to think of it is we're warm, say in eastern North Carolina, but there's a real strong cold front coming into eastern Tennessee and western North Carolina. That cold air is rushing to get into our area, and that difference in air mass ahead of it is very, very unstable because you have a difference between warm and cold air just to your west. So again, kind of a difference between warm and cold air. That's the scientific part. If you just remember high instability, more fuel, more potential for the storms to become severe if those other ingredients are in place. I want to stop at this point. I like this example to show you can have two of the ingredients, but if you don't have the third, then things don't happen. So we've got the moisture. This soda bottle represents the moisture would be the soda in the bottle. As I shake it up, the bubbles in the atmosphere represent the instability. And you can see this anytime. If you have puffy cumulus clouds that are not growing tall, or you have flat stratus clouds, not a lot of instability in the atmosphere. But if the clouds look real bubbly and they're starting to grow in the vertical, that's a pretty good sign that you have some instability. The last thing you need is kind of an acting agent to set everything off, and that would be some type of lift, and that would be from a cold or warm front. A cold front brings in cold air, hence it's named a cold front, but that cold air is very dense. So as it pushes in, it lifts the warm air in place up very abruptly. So apples to apples, you tend to have really tall storms, and they're very abruptly lifted up. Because of that, they tend to produce a better chance of severe weather. Can you get severe weather or even tornadoes with the warm front? Yes. But by and large, our bigger outbreaks are more associated with cold fronts because they force that air up very abruptly. And you get cumulonimbus clouds, real tall thunderstorm clouds instead of flat clouds. Speaking of flat clouds, that's what happens with the warm front. That cold air is in place. It doesn't want to budge. It's very, very dense. The warm air tries to come in, and it's lighter, so it just gradually rides up and over it. It creates showers and thunderstorms. And again, they can certainly be severe. We can certainly even get tornadoes from them. But if you look at the diagram, they're stratus clouds. They're much flatter, so they tend to not be as severe weather prone as the taller cumulonimbus clouds. All right, so we've thrown some science at you. We're about 20 minutes into the class, and by design, we try to put this up at the front. If you get nothing else out of this class, this is a slide I want you to get out. When you have severe weather, we prefer that you call our 800 number to report that information. Folks in Kentucky and Virginia that are on the call that are not in our local office, at the end of the class, you'll have my email. Contact me and we'll hook you up with your local office because your 800 number will be different. You'll want to call a different number. Spotter procedures are the same, though, no matter where you are in the country. As you call that number, we're expecting a severe weather report. You want to start off with that you're a trained SKYWARN spotter. what you saw, where you saw it, so your location, and when. All very, very important points, and that keeps you precise and directly what we want to need in terms of information, because we're very, very busy in a situation like that. We want to cut to the chase, but we want some accurate information. The where you saw it is important. The town that you're in, or if you're 2 miles outside of town, I'm 2 miles west of Morehead City, anything specific would be great. And the when is very important. Let's say that you take shelter, but before you do that, you saw large hail or a tornado, let's just say. You come out of your shelter 10 minutes later, you call us, be real clear that, hey, 10 minutes ago, I saw X, Y, or Z. Because the first thing we're going to do is we're going to look at radar, and if it doesn't match up, there's going to give us some confusion. So 800 number is preferred. We can ask you questions. I'm going to talk about supplemental ways, Twitter, Facebook, email. That's all great. And we do check those resources, but not as often as we pick up the phone. 24/7, we answer those phone lines, and that's why we prefer that you'll call us those severe weather reports. Again, that 800 number is on the screen. You can write it down, but if you're like me, I've got a million pieces of paper on my counter at home. It seems like an endless pile. Put it in your phone. More than likely, this will stick around longer than that piece of paper. And we'll go over the 800 number again. It is also on our website. And in my follow-up email to you tonight, I'm going to recover all of this, the different ways to report. So if you didn't get a chance to jot it down, you're going to see it a million different ways by the end of tonight. All right. Some supplemental ways to report are email. WeatherObs, wxobs.mhx@noaa.gov. Again, I'm going to email this to you, so don't feel that you have to jot it down. I say supplemental because we'd rather you call us, but then if you want to follow up with, hey, we've got quarter-size hail here in Richlands, can I send you a picture? Yes, this is where you would send that picture to. Same procedure. Who you are, you sat through a class on a Tuesday night that's gorgeous outside. Give yourself credit. I'm a trained SKYWARN spotter. This is what I saw. This is where I live and experience this severe weather, and this is when I saw it. Again, the email, good for pictures and videos and follow up with us on more information. All right, so we talked a little bit about reporting, and now you're going to notice a routine. We're going to talk about the different types of thunderstorms, how they are caused, and again, that's a little bit of science. But then we're going to go over they can produce hail or they can produce high winds. This is how we want you to report that type of information. I love this graphic. It's been around for a while, and we certainly want to keep it because I think it's a good one. We're looking at a scale from left to right in terms of intensity. You'll notice on the far left, the single cell, we mentioned weak updraft, just a fancy phrase for air moving up. It's not moving up super fast. Another phrase I want to throw at you is shear. There's a couple different types of shear. One is speed shear. That's where the wind changes with height. We might have really light winds at the surface and very strong winds aloft. That induces a rolling, a twist, a shear. The other shear is a directional shear. We might have south winds at the surface and southeast a couple thousand feet up. That change in wind direction can induce rotation, a shear in the environment. Don't need to know that, but just the science behind it. If we have weak updraft and weak shear, we're more likely to have a single cell storm. If we increase that twist or shear and we increase that lift in the updraft, we're more likely to get a stronger, more organized storm, larger threat for severe weather. Like to back things up with pictures, and this is what I mean by that. We'll start off with the single cell storm. Notice that we've got the moisture because you've got the clouds. It is bubbly in nature, so we do have some instability, but it's very in the vertical, very much up and down. And because of that, that reduces the storm's chance of lasting a long time. It goes from the developing stage to the mature stage to the dissipating stage like that, 15 or 20 minutes. And because of that, it doesn't have a chance to get a really, really large hail or a higher chance for severe weather. This is a beautiful cross-section of the storm of a single cell. We also call these pulse storms or garden variety thunderstorms. I'm a big rose grower. I love gardening. This is a type of storm where it hasn't rained in a week. You have a storm to your west, and you say, finally, I don't have to water the garden. I'm going to get a storm. And just before it gets to you, it falls apart. Doesn't last more than 15 or 20 minutes on radar, and then poof, a new one develops farther to your east. So these are ones that come up, come down, come up, again, and come down. They don't have a lot of organization to them. On this graphic, between 10 and 15 minutes, the red represents heavy rain, maybe some hail and gusty winds. It has collapsed on itself, and by minute 20, it's really falling apart. Because they're in the vertical, they're not balanced. They're going up, and they're collapsing, and by the time that happens, the storm weakens, and it can't reform. So these are called pulse storms. We do get these in the summertime. They're kind of borderline a lot of times. What I mean by that, we'll definitely get hail and gusty winds, but they're kind of on that threshold, between a 60-mile-per-hour gust and a quarter-size hail. Can we get large hail? Sometimes, yeah. Even an isolated tornado, certainly. But they tend to be not as organized and therefore not as long-lived in terms of severe weather potential. The point of emphasis with this, anytime you get hail, we want to know about it. Even if it's the size of a BB or a pea and it's really small, you're helping us gauge the storm. You may not even be under the worst part of the storm, and you might think, oh, my report is insignificant. It's not true. You're telling us what's happening in that part of the storm, and from that we can surmise in a more intense part of the storm, the hail is larger. So if you can, use some sort of reference. If you're like me, I rarely have these things called coins in my pockets anymore. I use the card all the time, so I don't have cash or coins. If you're like me, use a ruler, and you want to measure the widest part of the hailstone. Hopefully you're not doing this. A 5-inch hailstone would be pretty big. So again, measure the largest hailstone with a ruler or compare it to a known reference. Do not use marbles. You might say, well, Eric, why not? On this graphic, is it the gray one, the green one, or the red one? They vary in size versus a quarter or a penny is the same size. It's a standardized size. The lower right is a great example of how a picture can emphasize the report. Hey, I've got quarter-size hail. I want to shoot you a picture, and that's a great reference because you take away that coin, just kind of cover it up on your computer screen, and we know those are big hailstones, but they may even look like the size of golf balls if I don't have a reference. But now if I uncover that quarter and I can see it, I know that it has some reference, and I know how big those stones are. So to summarize, report any size hail. Make sure to give the biggest hailstone itself. So an example might be, I've got a lot of nickel-size hail, but a few are as large as the size of a quarter. So that's certainly useful information for us in terms of reporting. Certainly appreciate it. And again, even if it's small, don't think it's not a significant report, because that's certainly a good one. All right, we're going to switch things up a little bit, make sure everybody's still awake on the other end. So this is a poll question. When you call us, the first two things you should say are, number one is, I'm a train spotter and what you're seeing. Number two is, can you tell me the forecast for North Carolina? And number three is, when and where you saw it. So you go ahead and answer that. I'll give you about 10 or 15 seconds. We'll see how everybody's doing. All right, about 2/3 of you have voted, so we'll give it another 5 seconds. And of those that voted, you did an excellent job. So the correct answer is number one, I'm a train spotter and what you're seeing. Number three is close, when and where you saw it. That would be after that you say that you're a train spotter and what you're seeing. So that's very, very good. Appreciate the response on that. That's definitely a good one. And just kind of re-emphasizing what we want you to say when you call. One thing I forgot, kind of an easy one at the start of the class, I forgot to mention this. I just always curious, folks, is this the first time, second time they've taken a class? So is this your first weather spotter class? Just a simple yes or no. We see we got about 3/4 have voted, so we'll give it another 5 seconds. We've got a nice split going. 60% of you, this is the first time, and 40% this is you've taken one before. So that's excellent. I like to have a wide variety. I think it means that we're doing a good job, because those that have taken one before are still coming back. And for those new folks, I want to entice you with some other classes that we have down the road. This online spotter class is just the first that we offer in terms of classes for the community. All right, so I think we're back in business.
The conference is now in silent mode.
All right, so we last left off with definitely, reporting any type of hail. Think back to that diagram. We increase the shear a little bit. That's the twist in the atmosphere. And we increase the updraft strength. Because of the increase in shear, we're going to tilt the storm just a little bit. So what happens, since the storm itself is tilted just a little bit, it can maintain itself longer because it's able to ingest warm, moist air and have more longevity. So instead of being in the vertical, developing and just collapsing, since it's tilted, it can last longer. And a couple things can happen. Number one, you can have multiple cells and lines, and they can organize, and that enhances the threat for something such as flash flooding or flooding. So we certainly want to know about that. Sometimes we'll call this training, where a storm goes over the same area over and over again, and that can produce heavy rain in our area. We're lucky we have very sandy soil, so a lot of times it does take a tremendous amount of heavy rain to cause issues. But where we start to see some issues creep in a little sooner are more urbanized areas. So if we have some areas that have been paved over, some city locations, that can certainly cause an issue with us in terms of flooding. So anytime we get flooding, we certainly want to know that. Letting us know about that certainly helps with our warning program itself so that we can issue warnings if need be, or even a rainfall report itself. So we talked about flash flooding. We certainly want to know about that. And with regards to that, we're talking about something significant, something never seen before, or something rare. So we're not talking about the ponding that's at the bottom of your road that happens a lot. We're talking about once or twice a year or many years in between. And an example would be, roads are becoming covered with water. My stream is rising fast and approaching bank full. We want to know how deep the water is. I don't expect you to get out there with a ruler. So use your, references, tires, cars, roads up to the stop sign, that type of thing, as a measurement for how deep the water it is. If you have a rain gauge, even better. We threw out the number about 2 inches in a real short period of time or over a day. We're not going to be upset if you call an inch and a half in a half an hour. We just didn't want you to think that you had to report every raindrop. So something really intense in a short period of time or something cumulative, that is a lot. Want you to consider cocoa raws. This will be one of the links that I include in the email. It's cocorahs.org. Great organization that we work with to increase the rainfall reports coming into the Weather Service. They're used a lot of different ways than just the Weather Service itself. All the information you need is really on the website. On the site itself, you can purchase a rain gauge that looks like the picture on the left. It's a real nice, sturdy rain gauge. It's probably the elite of all rain gauges. You start with the lowest one, with kind of the test tube ones. Very, very narrow opening, not good at all. The next step up, which we use in the Weather Service, are called tipping bucket or self-emptying rain gauges. Those are the digital ones that you place outside, and from the comfort of your own home, you can read them. They've got a little seesaw in it, usually calibrated to 1/100 of an inch. Once it measures that, it becomes heavy, makes a contact, and comes back up over and over again. The downside on those is that it underestimates during really, really heavy rainfall. It's nice that you don't have to empty it. You don't have to go out and get wet. But again, it does tend to underestimate a little bit in those extremely heavy downpours. The elite, or the best one, would be this gauge. It's about $25 to $30 on the website. It's a 4-inch opening on the top, very, very sturdy. You can buy that from the website itself. There's a couple of vendors listed. There's online training. And once you get set up, you're all good to go. And in fact, one of the neat things about Cocoa Raws is not only can you log into the website, but you can do it on an app. The difference between the spotter program, our spotter program, again, is volunteer, and it's pretty much begging you, any type of severe weather you get, call us. Let us know about it. Cocoa Raws is a little bit more of a commitment. They expect you to report 7 to 9 each morning. The Cocoa Raws police is not going to come after you if you miss a day here and there. But again, a little bit more of a commitment. I would say if you have a weather station now, you're already documenting the weather. You have a child or teenager that can't get enough of the weather, this is something for them to do. If you're a teacher, somebody that's looking to get more science in the classroom, and you want to install this at the school and have students work on measurements and math, this would be up your alley. So all that information is on the website. And again, in my follow-up email tonight with your certificate, you'll get more information on that. So back to our diagram. We mentioned stronger shear, stronger updraft. We could get organized lines that produce heavy rain, or we can get organized lines called squall lines that can produce extremely strong winds. One example of this, sometimes you might see something called a shelf cloud. This is the exhaust of the storm, the rain-cooled air pushing out. Doesn't necessarily always mean true severe weather, but at the very least, a wind shift and winds are going to really pick up. And in some cases, like this picture, we had an 82 mile per hour wind gust. This is a couple years ago in late May down in Fort Macon. This is an example of a microburst. That's a PDF version, so it's not going to work. It looked like a hurricane or tornado or a tropical storm, very, very gusty winds, and we can certainly get strong winds with a microburst. Downdraft, straight line winds, you may have heard a bunch of different terms. Bottom line is you don't need a tornado to get devastating winds. In fact, some of those microbursts can produce winds up to or exceeding 100 miles per hour. So very, very strong winds can occur with just a severe thunderstorm, and that's why we issue warnings for those. So speaking of wind damage, you don't need a fancy anemometer. We just want to know what was damaged with your wind speeds. Any trees down, large limbs, small limbs, nothing. In that case, you wouldn't call us. But any type of wind damage that you have, let us know what's happening. We mentioned some supplemental ways to report. Again, this is not the first place I want you to put the severe weather report, but not a bad place to follow up with a picture would be Facebook. Anywhere on social media, Twitter, Facebook, or YouTube, you can find us. It's NWS Morehead City. Again, who you are, what you saw, where you saw it, and when are the most useful ways you can get that information to us. So we've made it to the end of our graphic, about 5 more minutes, and then we'll turn it over to you for some questions. At the far right end of that graphic was the supercell, the strongest updraft, the strongest shear in the environment. That's a textbook severe thunderstorm. The biggest one, the right side of the storm, or what we would call the front side, is the dark side, kind of the exhaust of the storm. That's where you get your heavy rain, gusty winds, and hail. The backside of the storm, or the intake of the storm, that's where your very, very strong updraft is. We call that a precipitation or rain-free base. That's where you're most likely, in a textbook scenario, a tornado would be. The thing about a supercell, they can last a long time because they're equally balanced. You think back to that single cell storm, you had it up, very, very strong in the vertical, so it collapsed very quickly. Didn't have time to maintain itself. With a supercell, it's constantly ingesting new warm air and also efficiently getting rid of it. So it's a balanced system, and because of that, it can last longer and has better potential for producing severe weather. We can certainly get textbook supercells in eastern North Carolina. I would say most likely inland. Kind of our tornado alley in North Carolina would be, I'd say Fayetteville, northeast through Rocky Mount, Wilson area, Greenville, Kinston, Edenton, Elizabeth City, kind of that area. And we can, every couple of years, we get outbreaks with true supercells that are very tall and very similar to what they would have in Oklahoma. Not as common, but we can get them. The other thing that we have maybe more commonly are called mini supercells. If you look on the left, that's the textbook definition, kind of showing a possible tornado where the hook echo would be on radar. That's just the precipitation wrapping around that circulation. On the right is a real-life example. This is a tornado approaching Atlantic Beach this past fall. I don't think it even had lightning with it. Very shallow. So from a textbook standpoint, very similar, just not as tall and as big as the ones they get out, luckily, in Oklahoma and the central part of the country. Another way we can get tornadoes are from any landfalling system. We had more than 15 with Florence. Again, the system's already rotating, so we can get those quick spin-ups, usually weaker. Usually folks aren't outside because they're hunkering down for the storm, but we certainly can get those. And with our proximity to water, especially the larger bodies, maybe just offshore the Outer Banks or the Pamlico Sound, Bogue Sound, a tornado on water is called a waterspout. Most likely they form over water. As they move inland, they would weaken really quickly. You could have a tornado cross into water, and that would technically be classified as a waterspout as well. And since it's getting away from its origination, its source, it would fall apart really quickly too. These are important to report to us because if you're a boater, they're not weak. But in terms of meteorology and the dynamics, they're very, very small. So often our radar has trouble seeing them as clearly as, say, a much larger tornado. So to summarize, and I think this answers one of the questions from before, tornadoes and funnel clouds, it has got to have rotation. Again, is it extending to the ground or not? That would be the difference between a funnel cloud and tornado. And is it over the water? Would be a water spout. Twitter is another way you can interact with us. Again, not the primary way. And you could do so at NWS Morehead City. All right, a couple quiz questions. I'm going to show you the pictures, and then we're going to use the polling system to ask those questions of you. So we've got nice still pictures. So I need to tell you that they are not rotating. So my question to you is, are these funnel clouds? Again, they look real gnarly looking. Take a real good look at the picture before I pull up the question. Are these funnel clouds? And the big key with that is they are not rotating. So we're going to load up the poll here. All right, so you should see the question, is this a funnel cloud? And again, the key is it is not rotating. So is it yes, it's a funnel cloud, or no? It's really good. A strong start out of the gates. We've got about half of us have voted. We'll give it about another 5 seconds. Again, is this a funnel cloud? And without even seeing the picture, the key is it is not rotating. So even not seeing the picture, me just telling you it's not rotating is a pretty big hint. So about 3/4 of you got it. That's real good. The answer for that is it is not a funnel cloud because it is not rotating. So the key with that is the rotation aspect. It's got to be rotating. Whenever we talk about tornadoes and funnel clouds, before we even get to is it in contact with the ground, got to be rotating. These are called scud clouds, scattered cumulus under deck. Good friend of mine up in the Utica area, a TV station up there, I just saw it recently on his Facebook page. I got to ask for that picture. Had multiple scud clouds hanging down up in the Mohawk Valley. A great picture because it looks like multiple tornadoes, but it's not rotating, so they were scud clouds. They can look really confusing, that's for sure. When we talk about tornadoes, we use the enhanced Fujita scale. We don't often, we're not able to measure winds in a tornado with a basic weather station. So what we do is we use a damage scale, and it'll tell us, we'll look at a binder. Is it a brick building? Is it a mobile home? Was it a hardwood tree, softwood tree? And we have an upper bound, lower bound, and an average of what the wind speed would be to cause that type of damage. And that's how we estimate how strong the winds would be, not only in a tornado, but any type of severe weather. That brings me to these two slides, and then we'll have a couple summary ones before we turn it over to you. If we get a report of a lot of damage, we'll go on what's called a storm survey. And we look at two distinct things. The first one is using that Fujita scale to determine how strong were the winds. And that's totally separate from what caused it. You could have a 60-mile-per-hour tornado and a 100-mile-per-hour microburst. A lot of people assume if there's a tremendous amount of damage, it has to be a tornado, and that's not necessarily true. So we'll look at our binder. What was damaged? Was the ground soft because of rain? Maybe the rating is a little lower. Was it a real sturdy building? So again, a lot goes into how strong the winds were. And then it's the pattern that determines if it's a tornado or not. We'll get a compass, and if we've got some uprooted trees, we'll measure the way that they're pointing. Unless they bounced into something or they're down a hill or something disturbed them, they're going to point in the direction they were blown. So if they're convergent or coming together, kind of a path or chaotic scene, that's more indicative of a tornado. If they're all in the same direction or even different directions, but we would call that divergent, one going this way, one going the other way, kind of a fan shape, that's indicative of straight line winds or microbursts. So again, winds can be as high as 100 miles per hour with a microburst. Doesn't mean that it's not a bad storm just because it's not a tornado. All right, one more quiz question. Same type of thing. I'll throw up the picture, and then I'll turn it over to you in the software to answer. So another still picture. Is this a tornado or funnel cloud? And the key with this one is it is rotating. So I'm going to let you stare at this one a little bit longer. And we know it's either, either tornado or funnel cloud. I said it was rotating. So the key on this one is look really carefully at the picture. Get your glasses on. Look really, really hard. So one more time, tornado or funnel cloud. And the key was it was rotating. So at least tells you that. So I'm going to turn it over to you on the poll questions. Let's see here. All right. Is this a funnel cloud or tornado? Yes or no? We'll give you about 10 seconds on this one. And these are not meant to trick as much as just really emphasizing the first one has got to be rotating. And this one is emphasizing, is it in contact with the ground or not? This is outstanding. 100% have answered correctly, and that would be yes, it is a tornado. And the reason for that is the debris on the ground. You can see that the circulation does extend to the ground, even though you don't see it in the middle, because of that debris on the ground, and that circulation does extend to the ground. Very, very good job. Quickly, M-ping is another source that you can report to us. This is used a lot for precipitation type. So I would say if you're avid into the weather, search your phone of choice, the app store itself, and search M-ping. You can download that, and that would be good, especially in the wintertime for the different precipitation types. But just another way you can report information to us. We do try to emphasize that your reports provide a clearer picture. We want to know about it as soon as possible. In the event you get back from vacation and you see damage, certainly can report it after the fact. Just let us know that, hey, I'm not sure when this occurred, other than it happened in the last 5 days because I've been out of town, that type of thing. But we can certainly look back at the radar and kind of confirm when that happened. A big myth that we already know what's going on. This is a big picture of a big tornado in 2014 up in Greene County up towards Snow Hill. Again, your block may have a lot of damage and you might think, wow, this has to be all over, when in reality it could be quite isolated and we might not know about it. So again, use that 800 number. Please make those reports. When should you contact us? A review, tornado, funnel cloud, it's got to be rotating, any size hail, wind damage, large branches down, trees uprooted, things like that. Any significant flooding, if you've got a rain gauge, even better, because that allows us to hone in on the radar and see how it's doing. Summary of the procedures, again, you're going to pretty much receive exactly this in your email, so we won't beat it into the ground other than to say the 800 number is the most preferred way. When should you not call us? I hesitate to say not because we want you to call, but if you don't have a severe weather report, hey, there's a lot of strong winds. Well, if you don't have some tree limbs down or branches down, it's not significant enough to let us know about that. And anything non-specific, it's raining really hard, it's really windy, that doesn't give us any precise either measurement or damage report. And reporting lightning is not necessary because we've got that information through a lightning detection system. Our goal, in addition to reporting, is to make you a year-round spotter. The Weather Service traditionally focused on the basic classes, and they're a lot of fun to teach, but luckily, in reality, your chances of seeing a tornado are low, thankfully. Chance of seeing hail, a little bit higher, and some heavy wind or rain, but your chance to report rainfall or even snowfall, much higher. So if you get snow in the fall and the winter, take that ruler, take a couple measurements to get an average, and report to the nearest tenth of an inch or any amount of ice. I'm saying that because it could be many years that you don't have to call us if you're just waiting for spring and summertime severe weather to report to us. Then you forget the 800 number, you forget to even call. If you get that CocoRa's gauge or you remember to report snow in the winter, you get into the habit, so that second nature, call us up when you get large hail or high winds. So again, the goal is to make you a year-round spotter. To support that, we try to do 4 classes or different class types throughout the year. I got one question from Michael about this. This is the last basic spring class as of now. May add a few more, but this is probably it for the year. So with that said, we're going to start planning a couple advanced classes. Most of those probably would be online. So that's a follow-up to this. That's more a gift to you. It goes into dual pole radar and some extra topics that aren't necessary for reporting. It's more just for knowledge. The sister class to this would be in the fall and winter. We've done that before. It's our basic winter class. And then we've done a flood tropical the first time last year, and those will be scheduled later this summer. We always post this information on our website. In addition, on our website, if you go to our website and you go down to the bottom and click on SKYWARN, the basic spring that you just took and the winter versions are on YouTube. So if we went too fast, a friend couldn't make it, you think somebody else would be interested in this, they can take the same thing. We broke it up into multiple parts. It's still less than an hour. Once they complete it, they'll just shoot me an email, and they'll be able to sign up as a spotter. Speaking of email, before I turn it over to you, that's our phone number, or at least mine here at the office. You can call, but the best way to get a hold of me would be the email address. So if you have any further questions about the class, you should all have that email because I just sent you the PDF before the class started. But look for my email later this evening with your course certificate, and then also that follow-up information on the phone number and the email and Twitter and everything else.